Calling all Umis! Team Umi Zumi!
1, 2, 3, 4, Umi! Zumi! Umi! Umi, Zumi, Umi, Zumi!
Hello, Earth citizens. It is Thanksgiving, and I would like to say thank you for your appreciation and your gratefulness toward our project, and a special word from Gobble Gobble.
This week we're doing the Path Builder. We're using the Maze robot and the Cage robot.
Yeah, using both these robots will basically allow us to get from one destination to the next and be able to navigate our facilities so
and
that
it'll also pick up the materials and bring it to our testing
right,
sites.
so that nothing gets stuck in the wrong place.
We made the robots like this to bring the materials over to the fusion reactor and have the construction be safety to make it more of a risk-free area for people that are constructing it.
So basically the whole point is to make construction, risk-free, and also to make it more efficient for our robots.
The Maze robot will help to facilitate the travel of the Cage robot while we're going through specific areas while we're building the nuclear fusion reactor.
And the Cage robot will be in charge of lifting these materials and transporting them to specific dedicated spots for the fusion reactor. They'll also be lifting them up and placing them on top of each other.
What are our design choices for our final and our biggest project so that we can get the nuclear fusion reactor built on Mars? What do we have? What robots can be used?
Well, there's the Cage robot, and it has good accuracy, but it's kind of costly.
Okay.
Another one's the football robot that has really good precision to get the footballs right at the aliens' feet to scare them off, but it's also really high cost for each of them.
Okay, sure, I guess.
We also have the crane robot, and it's really safe, but it's not very flexible.
Okay.
Yeah, the Maze Runner robot might be really good for this project if we want it. It is quite complex though, so there might be a downside, but it has great navigation skills. So.
Okay.
We could also potentially use the double line following sensor.
Mhm.
While it's highly accurate, it would be very expensive, and I don't know if it would be a good choice for this.
Right, okay. What robots can we unanimously say would be best? Because it seems like some of the robots may not be the best for this project.
I think the Maze or the Cage robot would be good because we're
Right.
trying to build and not
Okay.
get our robot stuck
Mhm.
to our fusion site.
Yeah, I think the Cage robot and the Maze Runner robot would probably be best for this project. I think for our final project, this will be the best. So, all right, thank you. Great job, guys.
Oh yeah.
Yay!
Thanksgiving! Why do you always clap?
Gobble gobble, Jackson.
Gobble gobble.
I'll tell you what.
For this Thanksgiving, for our last and final Thanksgiving project, the Maze Runner and the Cage robot are going to be the best. Through our simulated experiments, we were able to find that the Maze Runner was accurately able to go through and build with the Cage robot simultaneously building the nuclear fusion reactor on Mars. So both of these in conjunction with each other are going to be best for this project.
First, the code has the robot drive forward and then drive back and then turn right and then back to its original position in the opposite direction. And then it has to go in a square by repeatedly going straight and then turning right and doing that over and over until it gets in the original position. Then it turns left, goes backwards, and does that over and over again until it gets into its original position. Then it has the left wheel go faster than the right one so that it turns in a circle, and then it has them both go in the negative direction so that it goes back in a circle. Then it has on the Cage robot, this is the only difference that the Cage robot has, is that it has the arm go up and then back down to show that it's picking up resources. This first part right here, it basically establishes the sensors and stuff like that, the basic stuff that the robot needs to move around. This second part is the actual movement oriented stuff. So first it has it go straight in a certain amount of distance and then back in the same amount of distance. And then it has it turn right amount of rotations of the left wheel and then back the same amount of rotations of the right wheel. So it's in this original spot. Then it has to go forward amount of distance and then turn right a certain amount of rotations. And then it has that repeated over and over again with the same distance and rotations of the wheels. And then it has it go, once it's back in original position, it has the left wheel go a faster pace than the right wheel so that it turns in a circle back to its original spot. Then it has the exact same speed of the other two, just in a negative amount, so it goes backwards in the same direction. And the only thing the Cage robot does, it has the motor turn the cage 1/4 of a rotation and then has it go the negative 1/4 so it's back in its original spot.
We had a problem with our robots communicating, and the cage robot would get stuck a lot.
I solved this by changing the values of some of the blocks and moving them around so that works properly.
Another issue we had was the sensors aren't working because they're too close together.
We solved this by adjusting the timing and distance between the sensors to fix our issue.
Yeah, now all these are all solved.
I learned how to make the cage on the cage robot move to pick up resources and bring them to the nuclear reactor by going to a different motor and having it move like a certain amount of rotation to have it go up and down at the same distance.
This week I learned more about the cage robot. It works 24/7 and it can also handle more dangerous terrain. And also we worked more as a team this week. We created more of a checklist and started working and breaking down our video so we can get the grade that we want.
Okay, so what I learned this week was basically the importance of having the robots communicate with each other to have a successful project. Because it's really important that they work together and have like good communication and cooperation so that it actually carries out the functions and not just like a discombobulated project that doesn't even work. So yeah.
Over the course of the past few weeks, we've learned a lot as a team about teamwork and people being absent and learning how to problem solve. This week, especially, I've learned a lot more about coding and more about problems that we face and ways in which we can solve them and just staying focused as a team all together.
This week, I found the importance of making our team work schedule, which has been especially through this week, which has been kind of tough. So, getting our team to prioritize our recording schedule over having to do the document or any other major things, such as the iLearns that we're doing now. These doing this in the way that we did for this week has been able to get us through the week on a better schedule than any other week, especially this week.
I learned that it's way more efficient to use 2 robots instead of 1, even though it involves a little bit more coding. It's just way more efficient, 2 times better than 1.